Okay, so we are about to get started here. Again, hoping everything's working. Let me know audio errors or anything like that. Also, if you can, if you have any questions along the way, anything like that, then be sure to send me an email or a message on Edsby, and I'll be checking those throughout, and hopefully that will help out with everything. So what we have here is we're going to look at the quadratic equation and the quadratic formula, working with solving that along the way. And so here what we have is a little table that helps us determine when some good times to look at these are. So case here, and again, just for a sec. So I'm just making sure my audio is working here. Okay, so what we have here is a little table solving quadratic equations. You can use this to help judge when should you use which method. So you can always kind of try and graph an equation is what it's telling you here. The solutions won't always be exact, but it's a way to get a good, we just need an approximate answer when you're just looking for an estimation, a quick little look. Oh, what does it look like? Graphing's a good way to get an approximate solution. Factoring sometimes works. So if you don't have a C value, if you have a case of where it's just the ax squared plus bx and there's no C, then you can common factor out the x and solve it that way, and it's fairly quick. So you can sometimes use that. Completing the square always works. However, it's not always easily factorable, and in that case, it could become difficult finding that pair of numbers to get the exact numbers that work. Oftentimes, if b is an even number, as this is here, when b is an even number, that's a good time to use it. If b is an odd number, it might be more difficult of a solution. The quadratic formula, which we're covering, this one always gives the exact solutions, but it can just be more tedious because there's more work that you have to do with it. So if it's not easily factorable using the common factoring or completing the square methods, then the quadratic formula will always work. But again, you want to try and use the other ones when you can, just to make your life a little easier. The last one that's listed there is a computer algebra system, CAS. That's if you have some higher-end calculators that actually do the factoring for you and do all the work. It always works. It always gives the exact answers. However, those are generally the $70, $80, $90 calculators or more. You can use some of them. I mean, a modern take that was probably not thought of when this book was out would be a thing like photomath. The computer does all the work for you. So there's some options. Anyways, looking at the actual quadratic equation here, quadratic formula. So we use it to solve quadratic equations. We're often asked to solve or sometimes find the roots of the equation. But when you're given an equation, and I'm sorry if there's some extra noise here, there's people doing work outside, and it's getting a little noisy in here for me. But given an equation where you have ax squared plus bx plus c equal to 0, okay, and this is important, it does have to equal 0. In that case, you can use the quadratic formula, which is x equals negative b. So whatever the b value is, it becomes negative. So if it's a negative value, it becomes positive. So the opposite value, plus or minus, meaning that this is actually two equations in one, the square root of b squared minus 4ac all over 2 times a. And so when you fill that in, work that out, and that will give you the two possible solutions for your situation. There's two cases of things that we're looking for. We're either directly looking for the x-intercepts, such as this case here, when we just want to find where are those x-intercepts. So you might have an equation like 0 equals negative 2x squared minus x plus 5. We can then just sub that in for a, b, and c in there and get our two roots and find out what these are. The other case that we're working with it is when we're not explicitly finding the x-intercepts, but we're finding those 2 points when y is a number. So here we're finding 2 points that are across from each other along that line. Here we want to find 2 points that are across the line here. So we're really just shifting the graph around. And so you might have a situation like 4 equals x squared minus 4x minus 3. So here's your equation, and we want to find the 2 points where y is equal to 4. So when you're working with that, all you're doing is setting it equal to 0 by moving the 4 over and subtracting it from the other side. So you'd get x squared minus 4x minus 3 minus 4 in this case. And so you can just recreate a 0 equals equation by doing that and moving that number over. So you're either looking for these zeros and automatically we know y is equal to 0, or you're looking for the point where y equals a certain value, and then we just rearrange. Now to actually look at some of the questions, I got 4 questions. If you guys have other ones that you want me to look at, again, Edsby, or email me, and I can hook you up, or through the chat here, and I can do those ones. But I want to focus on a couple here. One E is one that I'd like to look at, and so 1E, looking at that here. 1E, we have 3x squared plus 5x equals 1. So 3x squared plus 5x equals 1. So in that case, what we're looking at is this. So we have to get it to an x equals, or sorry, the 3x squared plus 5x plus whatever equals 0. We got to get it equals 0. So we got to move this 1 over. We'll move it to the other side by subtracting. So we have 3x squared plus 5x minus 1 equals 0. Now we have it laid out with our a, b, c equal to 0. We can fill in the quadratic equation and solve this. So in this case, our b is positive 5 here, so we want minus 5 plus or minus the square root of 5 squared, b squared, minus 4 times a, which is 3, times c, which is negative 1, all over 2a, which is, again, 3. So we fill in our values, and now we just go about simplifying this step by step. Negative 5 plus or minus, and then within the root here, I have 25, and then negative 4 times 3 is going to give me negative 12 times negative 1 plus 12 in there. And that's going to be over 6. And then I get negative 5 plus or minus the square root. 25 plus 12 in this case is going to give me 37 over 6. Now, if we go back to the question for a moment, before we go any further, we're going to go back to that question. It does say, express the answers as exact roots. If you take the square root of 37, you will get a big, long decimal. If I do that, I'll pop my calculator out here. I'm going to do, clear that off. Where's my square root? Square root of 37. Hopefully you can see that. But if I do the square root of 37, I get 6.0827623. It's probably truncating that number to some degree. So it's not an exact root. So because I can't take the square root, get an exact number, I'm going to leave that one. So this question here, we just leave it like that when it asks for an exact root. You can calculate it, you can get two numbers, and when that is valuable to you, if you need to be able to graph this, or you need to be able to use that value somewhere else, then yes, go ahead, get it the decimal and simplify it. Or if it was, say, the square root of 36, well, we can just get that down to 6, and it makes it easy. But in this case here, because it's asking for exact roots, what that means is we are not taking the square root unless we can actually take the square root and get a whole number. So this is actually done. Now, let's take a look at another one. A little more of a process to it because it wants us to do some application of that. And so we're going to take a look at 3, and I believe I selected E. Let me double check here. I want to do E. 3A. Let's do 3A. So we're going to do question 3A. So if I switch over to the textbook here, we want to find the x-intercepts, the vertex, and the equation of the axis of symmetry of each quadratic relation, and then we want to sketch the parabola. So in this case here, we want the x-intercepts, so we want to know what the x's are when y is 0. Then we'll use those to find the vertex. From the vertex, we can get the axis of symmetry, and then we can do a sketch of that. So in this case here, we have y equals 5x squared minus 14x minus 3. And so when we're using this quadratic equation, quadratic formula, we need to make sure this is 0. So we set that equal to 0. And now we can substitute those values into our equation. So x equals positive 14 in this case because it's negative here. Remember, it's negative b plus or minus. So negative b becomes positive 14 plus or minus the square root of the b squared, so negative 14 squared, minus 4 times a, which is 5, times c, which is negative 3, all over 2 times our a, which again is which is positive 5. So we can simplify this down now. 14 plus or minus, and then in that root there, I'm just going to do it all in one quick calculation. So negative 14 squared minus 4 times 5 times negative 3 is going to get me the square root of 256 over 10. And I can get the square root of 256. So that works out to 16. So it's worth actually calculating. Divided by 10. And now we can simplify this by breaking it into two parts. So this is where we got to make use of that plus minus. So the plus is 14 plus 16 over 10, or x is equal to 14 minus 16 over 10. Two cases, that'll get my two zeros. And when we do that, we get 14 plus 16, which is going to give us 30. 30 divided by 10 is going to give us 3. Or 14 minus 16 is going to give us negative 2. Negative 2 divided by 10 is going to give us negative 0.2. And so now we need to find, so now we found the two x-intercepts. So if we were to start to apply this to a graph over here, quickly, just to show what we've found so far, a little sketch, make some axes, my x and my y. So we have a 0 at x equals 3, maybe somewhere over here at 3, and then negative 0.2. So we found these two 0 values here. This is what we found so far. And now, recalling that with a parabola, the parabola is symmetrical about any two pairs of points on the same line. So we can find the vertex, the x value of the vertex, by finding the middle of these two values. So the vertex, the h value, remember the vertex we often write as an hk. So our h value is going to be 3 plus negative 0.2 divided by 2. And when we do that, 3 plus negative 0.2 is going to give us positive 2.8 divided by 2, going to give me 1.4. So that's my h value of that. And then to get the k value, that is the y value of the vertex, we just sub in this into the original equation. So the y value, or the k, equals 5 times 1.4 squared minus 14 times 1.4 minus 3. So we calculate that. That will give us k. 5 times 1.4 squared minus 14 times 1.4 minus 3. And that gives me negative 12.8 as my k value. So my vertex, my hk, is at 1.4 and negative 12.8. So there's that work. Sorry if I had that off screen. So now I can plot that point on my graph. So I'll go over here, and we're looking at 1.4 somewhere around here, and negative 12.8. We'll say that's down here. So we'll call that negative 12.8, and this value here. We have enough to draw our parabola, so let's draw that first. So we get something looking like this. And then the other part was the axis of symmetry that it asked for. The axis of symmetry, remember, is that line that you'd put down the middle of the parabola so that it is symmetrical on either side. It's the line you'd put the little red mirror on, if you recall those, to mirror that image. So it's mirrored about that line, and the axis of symmetry in this case is x equals 1.4. So here we have a case where we had some decimals when we worked out our values, and it made sense to get the decimal values rather than leaving exact values, because we were using that later to find the h value of the vertex, and then subsequently the k value down here got us the vertex, which then we could plug in all our values, zeros, x-intercept, or vertex, and then the axis of symmetry, all in there for the graph. So that is number 3. The other ones I wanted to look at here, and we'll go with number 6 as the next one. So if we look over here to number 6, what we have is that the path of a soccer ball after it is kicked from a height of 0.5 meters above the ground is given by the equation h equals negative 0.1 d squared plus d plus 0.5, where h is the height in meters above the ground and d is the horizontal distance in meters. How far has the soccer ball traveled horizontally to the nearest tenth of a meter when it lands on the ground, and then find the horizontal distance when the soccer ball is at a height of 2.6 meters. So in part A, we want to know the 2 points when it's on the ground. So if we were to quickly sketch out the situation here, we probably have a graph, and we're not worried about the negative portion of the axis here, but we probably have a graph that looks either probably something like this, because it's kicked a little bit above the ground. So it might look, something like this is what we're looking at. And then we'll have these 2 zero values that we'll get from using the quadratic formula. And we will get one negative value, one positive value. And then the negative value we will disregard because we're not worried about that. We're just worried about this value, which will tell us how far the ball has traveled horizontally. So all we're doing in that case is just substituting, given the h equals negative 0.1 d squared plus d plus 0.5. So given that equation there, we are just setting h equal to 0 and subbing negative 0.1, 1, and 0.5 in for our a, b, and c in the quadratic formula, and then solving for those two roots. And again, we just keep the positive value because the negative value in this situation doesn't make any sense. But what I want to show you is the b portion of this, which is very similar, but other than instead of setting h to 0, we want to find the point where the ball is at a height of 2.6 meters above the ground. So we want to find, if this is 2.6, we want to find these two values here. So we want to find that value and that value rather. So in this case, what we'll do for the b part is we'll set the h equal to 2.6 equals negative 0.1 d squared plus d plus 0.5. And now we got to get this into a 0 equals. So we just have to move that 2.6 to the other side by subtracting. So we get 0 equals negative 0.1 d squared plus d plus 0.5 minus 2.6. And then we simplify that, and we'll have our a, b, and c values. So our a value stays the same, our b value stays the same at 1, and our c value here, it becomes negative 2.1. And now we have our ABC. We can plug those into the quadratic formula. X equals negative b, which is negative 1, plus or minus the square root of 1 squared minus 4 times a times c all over 2 times our a value. So we have everything, and then again to do this, we just simplify what's in the under the root, under the radical there. So we have 1 squared minus 4 times negative 0.1 times negative 2.1, and we get 0.16 over negative 0.2. Now, in this case, it makes sense to actually calculate the square root because, again, we're looking for specific values here. We want to find those two values and be able to state those, and we're looking at the values being in a useful position. So let's actually calculate that. 1 plus the square root of 0.16, which is going to be 0.4 over negative 0.2, or x equals negative 1 minus 0.4 over negative 0.2. And so we calculate both of those out. That'll give us our values. So we got negative 1 plus 0.4 divided by negative 0.2. So x equals 3, or x is going to equal negative 1 minus 0.4, and then divide that by negative 0.2, and I'm going to get x equals 7. So those are my two instances. At 3 meters and 7 meters is when the ball is going to be at 2.6. It makes sense to have two positive values because that's what it looks like in our graph. So that was the case, again, where you're solving for a not the x-axis. Along the x-axis, we're looking at somewhere above or below. The first portion, part A, would be done the same, other than you would have this negative point, or the last 0.5 as your c value instead of the negative 2.1. And then just to quickly go over the last question there, which was number 11. So in number 11, we had a toy rocket launch from a 3-meter platform at 8.1 meters per second. The height of the rocket is modeled by the equation given. So in there, you're given some information that you don't necessarily need. The toy rocket is launched from a 3-meter platform at 8.1 meters per second. You don't explicitly need to know that in this case because you have an equation here. But do note, and if you think back to the lesson where we talked about this, this relates to the acceleration due to gravity. So this is the force of 4.9, or the 9.8 meters per second squared. Acceleration due to gravity. This is what that is related to. This portion here is our initial velocity of 8.1, and then the plus 3 is our initial height. But they gave it all So this sentence is redundant if you recognize that our height, velocity, time formula gives all that information anyways. But all we need to worry about here is this formula. So after how many seconds will the rocket rise to a height of 6 meters above the ground? So to do that portion, we would set h equal to 6. So this is just like the last example we did. We set h equal to 6, and then you'd rearrange that. So you'd move the 6 over. It'd be negative 4.9t squared plus 8.1t minus 3 would end up being the equation. You'd sub the a, b, and c into the quadratic equation. That would give you two values for that, and those two values, it says how long does it take to rise to that height? You'd only be looking for the first value in that case, because in the second value you'd be coming down to that height, so you'd be falling down to that height because you'd go up past there and up to 6 meters, and then you come down past, unless 6 meters is the highest point, in which case both the answers would be the same. But in this case they're telling you that it's not, because the next part says when does the rocket fall back down. So the first answer would be the smaller of the two times would be answer to A. The larger of the two times would be the answer to B. And then use your answers from A and B to determine when the rocket reaches maximum height. There you're finding the vertex. So you're going back to the example like 3 that we did earlier. And you're going to take your two zeros that you find. You're going to plug in them into the and find the average in between them. And that'll give you the h value. Sub in that value to get the k, and that will give you the maximum height that rocket reached. So there we have the quadratic equation, working with that. Again, if you have other questions, feel free to email me or shoot me a message at ESB, and I can try and answer those for you. Otherwise, we'll be back next week with the last section of quadratics and just solving some problems with that. Again, you can ask me questions about anything along the way too. Otherwise, have a good week, and we'll see you next time.